Okay, I have to share this. I swear, if you've ever maintained a code base where, developers are just layering selectors deeper and deeper, or maybe two different naming conventions crash into each other, it's the
Uh,
worst. You spend hours fighting specificity, maybe even throwing in dot important just to fix one tiny thing. It feels completely broken sometimes.
that's absolutely the defining struggle for large front ends. And, well, that whole pain point is exactly why we need to talk about Meta's Stylex today.
Right. That's her mission here. We're doing a deep dive into Stylex. They bill it as a styling system for, quote, ambitious UIs that generates collision-free atomic CSS.
Mhm.
And the fascinating part is this isn't some small experiment. It's standard across Facebook, Instagram, Threads, and big names like Figma and Snowflake are using it too.
But that's right.
So we need to figure out how it manages to give you that like CSS in JS feel, but with static CSS performance.
Okay, so to really get the solution, let's quickly look at the problem context. At Meta's scale, they were drowning in issues. Style collisions, weird dependencies, those specificity wars you mentioned,
Yeah.
and these huge monolithic CSS bundles. Browsers were downloading hundreds of kilobytes of CSS rules they didn't even need.
Ugh. So how did Stylex pivot? It sounds like CS in JS, but you're saying it's different.
It looks like CSS in JS syntactically, but that's really just the form. Fundamentally, it's a compiler.
For compiler, okay.
Exactly. It uses Babel plugin. So at build time, it pulls out all those style definitions. It's not injecting styles dynamically at runtime like traditional CSS and JS often does.
Ah, so the magic is when it happens. Build time, not runtime.
Precisely. That build time compilation is what lets it generate a single super optimized static style sheet. And that optimization, it comes from its core idea, atomic CSS.
Atomic CSS. Okay, that rings a bell, but isn't that the approach where you end up with like 50 tiny classes on every HTML element? Makes the markup almost unreadable for humans.
That's historically been the trade-off, yeah.
Yeah.
Stylex fully embraces atomic CSS, so every little declaration like padding left 10px might become its own reusable class.
Right.
But crucially, you, the developer, never actually write or see those generated class names in your source code. The compiler handles all that messy output.
Okay, so it abstracts the mess away.
Exactly. It analyzes everything, deduplicates styles aggressively, and only spits out the single declaration classes that are actually used. They saw something like an 80% cut in CSS size because of this.
Wow, 80%.
And critically, the CSS size kind of plateaus. It stops growing wildly as the app gets bigger.
That kind of build time optimization is impressive. But, efficiency at that scale isn't just about code. It's about streamlining everything. Automation becomes key.
Absolutely. Couldn't agree more.
Which actually brings us nicely to our sponsor, Embersilk.
Yeah.
If your business is looking into AI, maybe for training, automation, integration, or even custom software development, Embersilk can help. They specialize in figuring out where AI agents could really make a difference for you, whether it's business or personal stuff. So check them out at embersilk.com for your AI needs.
Good stuff.
So back to Stylex. You mentioned the compiler handles the atomic CSS mess. What about the developer side? What's the API like?
It's intentionally tiny. Really just two main things. Stylex.create
Okay.
to define your style objects,
Okay.
which, by the way, get completely stripped out at build time. And then Stylex.props, which handles merging those styles together and turns them into the final class name string for your component.
Simple enough, but you hear a lot about its deterministic resolution. What does that actually mean? How does it solve my old important problem?
Yes. That's probably the most crucial part for avoiding those specificity headaches. Stylex enforces a simple rule. The last style applied always wins, period.
How? How does it guarantee that?
It calculates a numerical priority for every single CSS rule it generates, behind the scenes. So the compiler takes on the whole burden of figuring out specificity. You don't need .important, because Stylex already knows, for instance, that an active state should naturally override a basic style, or how a shorthand margin interacts with margin left. It makes complex merges totally predictable without you needing to think about selector weight.
That sounds incredibly helpful.
Yeah.
They also seem strict about encapsulation, right? Like no global styles.
Yeah, they strongly discourage what they call styling at a distance. So no complex global selectors that could accidentally affect components far away in the tree. It promotes keeping styles tightly coupled to their components.
And what about type safety? I see it uses TypeScript objects, not just template strings. Is that just nice to have, or is there a real benefit?
Oh, it's a huge benefit. Because styles are just JavaScript objects. Stylex can auto-generate flow or TypeScript types for them.
Okay.
This means you can enforce really sophisticated rules at development time, Like maybe a button component should only accept specific color tokens from your design system for its background color, not some random X code someone typed in.
I see, so it catches errors as you type.
Exactly. It bakes that safety right into your workflow,
Yeah.
preventing whole classes of styling bugs. And the best part, it has absolutely zero runtime cost because it's all checked at build time and during development.
Okay, so wrapping this up, Stylex focuses on compiling everything down to potentially one tiny static CSS file that loads super fast. That gets me thinking. Well, if a compiler can make all your CSS small enough to just load instantly up front, does that make the whole complex dance of figuring out and injecting critical CSS kind of obsolete? Like maybe just an old performance hack we won't need anymore?
That's a really interesting thought.
Yeah.
It definitely suggests that maybe the industry could rethink some of those complex runtime performance strategies if build time tooling gets this good.
Food for thought, definitely. Fantastic stuff. If you enjoyed this deep dive, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.